The science behind time travel. Is it possible? Hey there, time travelers. Ever wondered what it would be like to journey to the past or leap into the future? From mind bending movies like Back to the Future to captivating novels such as The Time Traveler's Wife, time travel has tickled our imaginations for ages. But here's the big question: is time travel just the stuff of science fiction, or could it be real? Today, we're diving deep into the science behind time travel to find out if hopping through time is actually possible. Let's get started. Historical concepts of time travel. First stop, a trip down memory lane. No DeLorean needed. Ancient myths and legends from around the world often involve characters who sleep for years or experience time differently, hinting at early fascinations with time manipulation. Fast forward to 1895, when H.G. Wells published The Time Machine, igniting our modern obsession with the concept. Since then, time travel has evolved, weaving its way into countless stories and sparking endless curiosity. Einstein's theory of relativity. All right, let's get scientific. Albert Einstein's theory of relativity revolutionized our understanding of space and time. Special relativity introduced the mind-blowing concept that time isn't absolute. It can speed up or slow down depending on how fast you're moving. Think of space and time as part of a single fabric called space-time. Then, general relativity takes it further by showing how massive objects like planets and stars can warp this fabric. This warping affects the passage of time. These theories aren't just abstract, they're the foundation suggesting that time travel, at least to the future, could be possible. Crazy, right? Time dilation explained. Time for some time dilation. According to special relativity, the faster you move through space, the slower you move through time relative to someone standing still. Sounds wild, but experiments prove it. Scientists sent atomic clocks on fast-moving airplanes and compared them to clocks on the ground. The airborne clocks ticked slower. This means that, in a sense, we can travel into the future by moving really fast. Einstein wasn't kidding. Gravitational time dilation. But wait, there's more. Gravity also plays tricks with time. Thanks to general relativity, we know that time passes slower in stronger gravitational fields. If you were near a supermassive object like a black hole, time would slow down for you compared to someone far away. Even here on Earth, GPS satellites have to account for gravitational time dilation to provide accurate location data. Without corrections, they'd be off by kilometers. Wormholes and bridges in space-time. Now, let's jump into the really mind-bending stuff. Wormholes. These are theoretical tunnels or shortcuts connecting distant points in space-time, kind of like cosmic cheat codes. The idea comes from solutions to Einstein's equations, known as Einstein-Rosen bridges. If we could somehow create or find a stable wormhole, it might allow us to travel between different times and places. Sounds awesome, but there are massive challenges, like preventing the wormhole from collapsing. Quantum mechanics and time travel. Quantum mechanics time. In the tiny world of particles, things get super weird. Quantum entanglement, where particles become mysteriously linked no matter how far apart they are, hints at phenomena that defy our normal understanding of time and space. Some scientists speculate that quantum mechanics could offer loopholes for time travel, although it's all very speculative and seriously mind-boggling. It's like the universe's way of keeping us on our toes. The grandfather paradox and other time travel paradoxes. Let's talk paradoxes. The famous grandfather paradox poses a big problem. If you traveled back in time and prevented your grandparents from meeting, would you still exist? This paradox highlights the issues with changing the past. It challenges our concepts of causality, the idea that cause precedes effect, and the one-way arrow of time we experience. These thought experiments show just how complicated time travel could be. Possible resolutions to paradoxes. So how do we solve these paradoxes? One idea is the Novikov self-consistency principle, which suggests that events in time are self-consistent. You can't change the past because your actions were always part of history. Another hypothesis involves parallel universes or the multiverse theory, where each decision creates a new branching timeline. These concepts could potentially sidestep the paradoxes of time travel, but they're still highly theoretical. Current scientific endeavors. What's happening in science today? Researchers are exploring the boundaries of physics, from studying black holes to experimenting with quantum particles. While we don't have a time machine yet, advances in technology and theoretical physics are constantly pushing the envelope. Scientists like Kip Thorne have contributed to our understanding of wormholes, and projects like the Large Hadron Collider are delving into the fundamental nature of reality. Who knows what we'll discover next? Philosophical and ethical considerations. Time travel isn't just about science, it's also about humanity. If it were possible, what would it mean for free will? Could altering the past or future have unintended consequences? There are ethical dilemmas to consider, like the responsibility of changing historical events. Plus, is society even ready to handle the power of time travel? It's a topic that invites deep philosophical questions, definitely food for thought. So, is time travel possible? While we don't have concrete answers, scientific theories provide intriguing possibilities. From Einstein's relativity to the mysteries of quantum mechanics, the door remains open, if just a crack. Whether or not we'll ever journey through time, the quest itself inspires wonder. Thanks for joining me on this temporal adventure. Don't forget to like, share, and subscribe for more explorations into the unknown.